Hey all, welcome to Tech Forum. In this video, we are going to talk about GraphQL schema stitching. GraphQL is a query language and a technology for APIs, created by Facebook in 2012 and made open source in 2015. It lets clients request exactly what they need from an API, nothing more, nothing less. The QL in GraphQL stands for query language. It's an alternative to REST, which is another common method for building APIs. Basically, GraphQL allows for more structured and efficient data queries. Why do developers like to use GraphQL? GraphQL is different from a RESTful API in some key ways. With RESTful APIs, you often don't know what data you will get without specific documentation. But with GraphQL, you can specify exactly what data you need and receive just that all in one API request instead of several API calls. Another feature is its introspection ability. This means you can understand and work with an API programmatically even if it is your first time using it. The biggest advantage of GraphQL is that it gives front-end developers more control over data. Whether they are working on a mobile or web app, they can select data more efficiently. And there are more. GraphQL is composable. This allows developers to combine multiple GraphQL APIs into one unified API. The main part of every GraphQL API is its schema, which defines how the data is structured and accessed. If you see this diagram, clients make specific queries to the GraphQL server and get responses. GraphQL server enables the API schema to define the structure of the APIs and manage the queries through specific resolvers. The resolvers handle data for specific queries by interacting with different systems. These systems can be anything. It can be a REST service or another GraphQL service. Even you can integrate with the DB. Let us quickly see a sample Open GraphQL service. This is the Open GraphQL API. Provides details about countries, continents and languages. So this is the URL for the API. I am using Apollo Studio to test the service. Let me click on Run in Explorer. So let me run the introspection query. So let me go here. It's fine. You can see all the types and fields here, like continent, continents, countries and country language. These are all the types available. Let me quickly test a sample query. I'm going to use query, then country. Maybe I will select capital. You can select any other fields required. Capital, then go with currency. Then you can go with name. Even if you want, you can select languages, name. Is fine. Let me execute query. So I need to pass the code as the variable, country code, query. Yeah, I'm getting the details back. So only I'm getting the selected details. So I requested for capital, currency, name, then languages, only the name. So I'm getting those details only. Let us now talk about schema stitching. Schema stitching is like creating a big puzzle from smaller pieces. It involves combining multiple smaller GraphQL schemas from different sources into one large schema known as the gateway. This gateway acts like a proxy layer that clients can use to make requests. If you see this diagram, the gateway proxy schema is created with multiple subschemas, subschema 1, subschema 2, subschema 3. Each subschema can represent a different services. When a client sends a request to the gateway figures out which part of the combined schema or subschema is responsible for the requested data. It then forwards the request to the appropriate subschema. Each subschema handles its part of the request and the gateway brings all these pieces together. It sends the complete data back to the client. The client unaware of the behind the scene process, so how the proxy is getting the data. With schema stitching, developers can also expand or modify the existing structures and functions of the schema. This makes the client experience seamless as they can access wide range of data through a single unified schema. Some of the benefits of schema stitching. One is modularity. Schema stitching lets you break down your API into smaller manageable services. The next one is code reusability. You can reuse and extend existing schemas, which reduces duplication and supports modular development approach. The next one is seamless client experience. Clients get to interact with just one schema, even though it's made up of many subschemas. The next one is simplified data fetching. Instead of sending multiple queries to various services, clients can get all the data they need with just one query to the unified schema. The next one is improved maintainability. Each service can operate independently and grow. The next one is easy integration. The integration becomes very easy considering the gateway takes care of communicating with multiple subschema and services. Let us now see a quick demo. I am going to use two open GraphQL services. One we already seen, the country service. Another one is SpaceX GraphQL API. This provides the details about SpaceX and rocket launches. Let me quickly test the SpaceX API. So query, I'm going to maybe get the company name. So edit, maybe I will get the CEO, that's fine. Maybe employees, maybe name is fine. Query, yeah, I'm getting the basic details. I'm using GraphQL tools to stitch the schema. I'm using these packages: executor HTTP to fetch the remote schema, then stitch, then delegate to delegate the queries to the remote subschemas. Then I'm using wrap to wrap the schema, then again schema. Also I am using Apollo Server Express and Express. As a first step, I am just creating the HTTP executor for these two endpoints, the countries endpoint and SpaceX endpoint. Then as a next step, I am creating a remote subschema using this executor. If you see schema from executor, I am passing those corresponding executors, countries remote executor and SpaceX executor. So now I have the executor and the remote subschema. So we can go with the stitching schemas. So this is the method for stitching schemas. This is from GraphQL tools. Subschemas. So I'm specifying schema. What is the schema name? Countries remote subschema. Then corresponding executor. Same way schema, SpaceX subschema and the corresponding executor. This executor is required. Why? Because during the runtime, the gateway need to send the actual request to this subschemas through this executor. Now executor is ready. So I am just starting the Apollo server through this gateway schema and using the Express. So now the service is ready. The service is going to run here. Technically we are stitching these two schemas, the country schema and the SpaceX schema, through a gateway schema, the common schema. Now through this combined gateway schema, we can access both countries and SpaceX GraphQL APIs. Let us now quickly introspect the gateway service running on localhost 4000 GraphQL. Even you can see the combined fields and types in this Apollo Studio. You have types from SpaceX API, also the types from countries API, countries, country, and let's even execute this introspection query. So it will show you all the combined fields, continents, then countries. This is from countries API, this country language, these two. Also if you go to capsule, and this all from SpaceX API. Now the gateway schema combines both countries and SpaceX APIs. So the queries against both of these subschemas can be executed through gateway schema. Let us now quickly execute a query that fetch data from both of these subschemas. So let me add this query. This is fine. Now I am going from country. Now I may select again country name. This maybe what else? Maybe capital. This is fine. Again I go and select company, CEO, then maybe name, maybe summary. So let me execute this. I need to pass this code. This is fine. Let me execute again. Now I am getting the data from both these schemas. So if you see country, then company. Technically, the gateway is delegating this request to the corresponding subschemas. For country type, it's sending to country API, and company type, it's sending to SpaceX API. Let us now see how to handle a conflicting scenario. Means two APIs has same types. Let me show that. I have a local GraphQL service that has this type, country, ID, then name, and the query is again country. So this is again running on 4001 port. So just sending a hard-coded country value, code is whatever the code we are receiving, and name is hard-coded country 1. So even I can execute this individually. If I go here, fine, maybe let me clear this, add this query, I will add the country, then maybe name. That's fine, I need to pass this country code. If I execute this, I'm getting the hard-coded country 1. So this is fine. Let me now add the local service part of the gateway schema. So for that again, executor 4001 port, this is fine. I'm creating a local subschema again with that corresponding executor. So again I am going and adding here the local schema. So this is fine. Let us again go and execute the same query. So now I am getting error, cannot query field capital on type country. Because both the country APIs are conflicting now. Also one of the API doesn't have the field capital. Let us now see how to use transform methods to resolve the conflict. I am using the transform to rename the types and queries. Rename types country to local country and rename root fields country to local country. So I am doing this on the country's local subschema. Also wrapping this as a new schema, transformed local country schema. So now I will go to the schema stitching. I will remove this local schema and add the transformed schema. This is fine. Now I will go and execute. Now if you see, I am getting the response. Now let me fetch the local country name. This is fine. I'll go and add the parameter US, execute. Now if you see, I am getting error. So it's saying cannot query field local country on type query. Did you mean country? Also I am getting other values. If you see, local country is null, but remaining values I am getting. So let me go back. So the reason is because only gateway schema knows local country, but there is no resolver or the API defined. So for that I am going to add a resolver here. So local country, if the query comes as local country, the request should be sent to country's local subschema. As this is kind of delegate to schema. So the any request for local country is delegated to this country's local subschema, and the field name is country. The local country is mapped to country field of this specific API. Now this is fine. Let me go and execute again. Now if you see, I am getting the response. This country response is from country's API, open API. Then this is from SpaceX API. This local country is from my local API. The custom resolvers are needed when using stitch schemas. One is handling complex queries. Sometimes default way of combining schemas might not be enough for complex situations. The custom resolvers let you add extra logic for these scenarios, like changing input arguments or even changing the data we get it back from the subschemas. The next one is linking data across services. Let's assume you have related data spread across different services. The custom resolvers can help to fetch and merge this data. The next one is data transformation and aggregation. You can use custom resolvers to transform the data from multiple APIs, and also if you want to aggregate the data across different services. Also custom resolvers provides consistent error handling and logging. Also if you need to add new features to the existing queries or create new ones, the custom resolvers can help. The schema stitching does the heavy lifting in combining schemas, but custom resolver give you the flexibility to handle more complex scenarios. Let us now see how to invoke a REST service through this gateway. I have a simple REST service running in my local. If I go here, so this returning user's detail based on the user ID. user/id. So it returns the corresponding user details. Let me try to execute. It's running on localhost 3000. So let me go here. Localhost 3000. You need to put users, maybe the user ID 1. So I am getting the user details here, name, username and email, also ID. Let me now integrate this service with gateway. As a first step, I am going to define a schema to match the REST service. So type user, ID equal to ID, then name string, username, then email. Also type query get user. It requires the ID as the parameter. So this looks good. So here I am matching it, but even if you have a REST service, the structure is different. So you can transform it. I will show you where to do that. So the schema is now ready. Now you should make this as executable. Make executable schema from this type definition. So this is fine. Now I have the executable schema. I will go here. I will uncomment this. I am passing the schema. No executor is required because we are going to handle this in a different way. So I am just passing schema, user schema. This is fine. Now we need to define a custom resolver to handle this specific query. So if you see here get user, getting the ID parameter and sending the request to the REST service and passing the same parameter ID and getting the response back, response.data, and this data is going to be combined with other responses by the gateway service and sent to the client. So if you have a structure difference between your schema and the REST service, you can do a transformation once receive the response. Let me uncomment this. This is fine. Let's now go and test it. If I go here, so this is the one. No, yeah, this is the one. So fine. Let me go and add get user. This is fine. You are getting it. Now what are the parameter we need to get it? Maybe we can get ID, name, email, then we can even get a username. This is fine. We need to just to pass the parameter. This is one. Fine. Execute the query. That's fine. Okay, get user, you are getting ID equal to 1. This is coming from the REST service. This is coming from the country's remote schema. Then this is from SpaceX API. This is from my local service, GraphQL service. Technically, now the gateway combines the responses from all these 4 APIs. The schema stitching is very helpful to build a composable service layer. The gateway enables a unified service API and handles the complexity of delegating the request to different subschema services. The gateway receives the response from multiple sources and combine and send to client. From client perspective, always invoke the unified API by specifying the required data fields, and the gateway handles the complexities. Thanks all for watching the video. See you all in the next video.